Sure.
Thank you. Okay, it's certified right now, so we can start the presentation today. And good evening again. Here's Douglas, Connex FAE, and I will handle today's presentation for the Layer 2 generic features introduction and conclusion guide. Can you show the screenshot, the screen which I shared? Hello, can anyone see the screen which I shared?
Yeah, we can
on
see the screen.
Teams? Okay, thank you. Because I'm not sure about that. Okay, and the voice, if the voice is not loudish, please let me know. I will control that. And here's today's agenda. We will start from the VLAN and then go to the port trunk LACP, IGMP snooping, and courier, and then go to the link layer discover protocol, simple network measurement protocol, which we usually call the SMP. And after that, we will take a break for 5 minutes, and then go to the next topic, the security feature. That include the general security feature and the cybersecurity features. So any questions? If not, we can start from the VLAN part. So for the VLAN, the full name of that is a virtual local network, virtual local area network. And the VLANs allow you to simplify the physical interface of one Ethernet switches into different segments. That means you can follow your request to simplify the traffic to different parts in one switches. For this example, we can base on a request like 3 different departments to simplify the network, even the equipment is in different floor. And the VLAN is a broadcast domain. The traffic between the different VLAN will be blocked, like the up or the usually you use the VLANs to simplify the broadcast domain. So we can use that to let the broadcast less than usual with the without the VLAN. And the VLAN we usually use the IEEE 802.1Q, and that is using the VLAN tag. We usually call that the VLAN ID on the flag to identify which VLAN is used to that network. And here's the VLAN policy. From the beginning, if we want to use a VLAN, we need to do the network play about the VLAN numbers. For the maximum VLAN support in our equipment, usually support the 256. And for the VLAN ID, we can use the VLAN 1 to VLAN 4094. Also, we can use the port base or the 802.1Q tag, the different type. But usually we'll suggest to use the 0.1Q tag. That is more common in the world. And after define the VLAN numbers, then we need to add the VLAN in our switches. So we need to create the VLAN for switches and enter the VLAN ID which you want to use to the VLAN database. And after define that, we need to set up the ingress rule about the port VID. The port VID, which we usually call the PVID, is for the untagged package which incoming from the port. So if the port catch a package which without the VLAN tag, then we will base on the PVID to add the VLAN tag on the package. And also we can define the filter for incorrect tag flag. We will show the settings later. And after finish the ingress rule, then we go to the VLAN members. For VLAN members, we will do the filtering database with the main table. The main table includes the VID, member pro, and the tag untagged. The tag untagged is also used for the last part egress rule. The switches will base on the setting for the tag or untag to send out the package. If we use the untagged, the switches will remove the VLAN tag before the package sent out from the port. And if we set up with the tag, then the switch will keep the VLAN tag on the phone, on the package and send out. So any questions? If not, then we go to the examples for the VLAN. If we use a VLAN between the two switches with a frame tagging, a short tagging is applied to every frame that crossing the network backbone. For example, the backbone is between the switch 1 and switch 2. So the package between the two switches is tagged. So the tag identifies which VLAN from the frame belong to. And also, if we edit the traffic in uplink port, we can use a tag or untag, depending on the request from the customer. And for this part, we use 802.1q trunk application. And for this example, if we send the package with a V1 through the port between the two switches, the V1 package will include the VN tag V1 to send out the other switches and send out a defined port, which will join the V1 members. And then we go to the ingress rule for VLANs. For ingress rule, the first part is for the port VLAN identifier, which we call the PVID. After we set up the PVID, the switches will add the VLAN tag with the VLAN ID which you define on the port to the untagged frame which you receive. And also, if the package already have the VLAN tag, then the switches will keep the VLAN tag which already tagged on the frame, sent to and receive the frame. For this point, then we need to notify that one port will only accept to set up one PVID. Because if we set more than one PVID, then the switches will not able to define which PVID should be taken on which frame, because the frame always untagged. And the second part for the ingress filter. Ingress filter is the other functions we can choose to enable or disable on the switches. If we enable that, the switch will check the package which received by the port is joining the VLAN member or not. For example, if you set up the VLAN 20 on the port 1, and the port 1 receive a package which with the VLAN tag 20, then they will receive the package. But if they catch a package with the VLAN tag 30, then the package will be dropped. And just as I say, if we disable the function, then no matter which VLAN ID, the port join, all package will be received by the switch. And this is an example for the VID versus the PVID. Follow this define, then the port 1 uses PVID 1, port 2 uses PVID 2, and so on until the port 6. And once the port 1 receives the package with untagged package, then the result is the untagged package will be added a VLAN tag with the VID 1. And so on port 2, we will take the package with the VID 2. But if the switches receive a package we already tagged, for example, on the port 5, the port 5 PVID is 5, and the port receive a package with a VID 1. The package will keep the VID 1 in the switch. They will not replace the VID 1 to VID 5. And then we can go to the egress rule for VLANs. For the egress rule, we can simplify to two parts. The first one is the untagged mode. If we choose the untagged mode, the switch will remove the VID and forward frame. And if we if we choose the tag mode, the switches will reserve the VLAN ID to forward the frame. For example, for the VLAN 1, if we choose the tag mode between the two switches, the V1 package will keep the VLAN ID 1 to the other switches. And if here we choose the untag mode, then the V1 tag will be removed and send out a package without the VLAN tag. And if we use the 1Q trunk link, then the trunk link will only allow the tag back. And for the VLAN, we go to this part to how the traffic goes. For the traffic, we will check the tag on the incoming frame. This is the first part. Just as I said before, if the tag, if a frame without the tag, then we will add the tag with a PPID. And if the frame already have a tag, then we will remind the VLAN. In the example 1, if the port 1 defines the PPID 1, and incoming frame with the tag PID2, the frame will check the VLAN member with the VLAN 2. And for port 2, PPID is 3. The incoming frame is no tag. The package, the frame will be added the VLAN tag 3 and check the VLAN ID 3. And the example 4, example 3 is a port 4. PPID is 99, incoming frame with no tag. The frame will be checked in VLAN 99, and also we can CO. Here's a table. Just for the example 1, the port 1 receive a package VLAN ID 2. The port 1 receive a VLAN ID 2, so they will send to the port 1 and the port 4. And for example 2, the package without no tag, and then the frame added the PPID 3. So they will check with the table, the PPID 3 only join the port 4, so the package will be sent to the port 4. And the last example, they will check with the VLAN 99, and the VLAN 99 already join all ports from 1, 2, and 4. So the device on the port 1, 2, and 4 will receive the package. And then for the VLANs, we also can use with the MVR. For the VLANs, we can use several RSR ring in one switches. We also call the multi-ring. If we use the multi-ring without the VLAN settings, the traffic between the different rings can discuss with each other. So the traffic will be through every rings in the switches. But if we binding the VLAN settings with the ISR, the traffic will only keep on their single rings, so the traffic will not flooding on every rings. We can use that to simplify the traffic. So here's a VLAN frame introduction. If anyone has do you have any questions about that? Okay, if not, then we can go to the configuration on our equipment. Here's a VLAN configuration example. On our equipment, you can define the major VLANs on this page. The data is on the VLAN setting page. The management VLAN means the device management IP with the VLAN. If the pole do not join the major VLAN ID, then you cannot control the equipment through the correct IP and VLANs. We will introduction this part for later over security. And then the second part is the static VLANs. We use this part to create the VLAN ID and the VLAN names. The VLAN ID is the mask part, and the names you can use that to identify the usage of that VLAN. And for static VLAN configurations, we can use this part to define the pole is joining the VLAN or not, and also include the egress rule, like the tag or untagged mode. And here's a command, you can reference that later. And here is a VLAN pole configurations part. So first, we can define the PVID part, which we discussed before. The PVID is using for the untagged package. If the pole receive a flag which without the VLAN tag, then they will based on the PVID settings to edit the VLAN tag. And the trunk mode is using for the Q&Q settings. And the accept frame type that is using for ingress check. For example, if you use the admin O, that means no matter which frame type, the pole will receive that. But if you use the tag only, then the untagged frame will be dropped by the device. And also, if you want to use the accept frame type, then the ingress check filter also need to enable. The ingress filter, they will also check the pole is joining the VLAN member or not. Just as I said before, if the pole 1 is a member for VLAN 20 and enable the ingress filter, the pole, once the pole receives a package with a VLAN 30, the VLAN 30 frame will be dropped by the equipment. And for the COI, we can use the show VLAN manager, show VLAN, and show interface to check the information of the VLAN settings. Hello? Okay. So show VLAN is using to check the list of the VLAN settings with a name and which poles join the VLAN. And the show interface is using to check the PVID on that pole. And also we can use a show run config to display all information at one time. They will include all settings on the equipment. So we can show the VLAN settings, the list settings for PVID, and also this settings for the untagged frame, and the trunk allow settings for the tagged frame. Okay, so the VLAN part is finished. Do you have any questions?
I had one question. In the
Yes,
world
please.
that I came from, I'm going back in time here, so excuse me. I thought in some switches, maybe not Cornix, that everything belonged to, there's a default VLAN 0. And I didn't see anything like that mentioned here. Is there a default VLAN 0 that everything is in unless you start enabling VLANs?
Default VLAN 0. Because in 1Q settings, the 0 should be not used because the VLAN setting is using from actually you can use the VLAN ID is from the 0 to 4096, but the first 0 and the last 4096 is not usable.
Okay.
Because there is a the 16-bit settings. So if
All
you will say there is a default VLAN 0, maybe that means the port is not using any VLAN, but usually we will use the VLAN 1 as a default VLAN.
Okay. And one other question is, in 802.1q, there was a feature called authentication. Is that something you'll talk about later? In the
authentication, you mean the Q or X? Because if you use the authentication, there will be use
X, yeah, maybe.
Q.
Yeah, 802.1x. Will you talk about that later at the end of the presentation today?
Yeah. That is in the security part.
Okay, thanks.
Okay, thank you. So, does anyone have any other questions? Okay, if not, then we can go to the other topic. For the second topic is a port trunk and LACP. Actually, that is the same function, just use different settings to do the features. For the port trunk, we can group multiple Ethernet port in order to increase the bandwidth. The aggregated port can be viewed as one physical port. For example, if you bind in port 1 and port 2 in a single port trunk, in the switches, they will be defined as a one port. So the bandwidth will be included. If the port is 100, if a port is one gigaport, and you bind in two ports together, then you will get a 2 gigaport traffic, 2 gigaport bandwidth on the port trunk settings. And please notice that if you want to use the port trunk, the speed duplex port setting should be the same on the two ports. And once you use the port trunk, they will balance the loading and back up with each other. This is an inexpensive way to increase the bandwidth without the upgraded equipment. And for the port trunk, we can use a static trunk or the 802.3 AD LACP to fulfill the features. The LACP usually called actually the LACP is a link aggregation control protocol that is using to binding the multi-port as a single port trunk. And for the LACP, they allow the network devices to detect multiple links between themselves by sending the LACP flag, which we call the LACP DU, and then combine them into a single logic link. So you can see, that means even you binding 3 or 4 physical ports into one LACP trunk, they will be combined in a single logic link. And also confirm the LACP configuration at the other end can well finished by the LACP PDS. This function also used to discover indirect link fails. So we can use that to fail over while the port link is failed or LACP DUs are lost. So for the port trunk, we have 3 different aggregation status. The first is aggregated, the second is individual, and the third part is a link down. For the aggregated, they will be shown with a static pole trunk and LACP. If you use a static, that means the all pole of the link is workable right now. And if you use the LACP, that means the pole is aggregated with the LACP member pole. And the second status is individual. Individual will only display when you use the LACP. And in this part, that means some part of that LACP setting pole is not workable. But still some pole is working, so they will not show the link down. And the last status is the link down. That means no matter you use a static or LACP, the setting is enabled, but the pole is not linked. And here's the configuration of the LACP. You should choose the pole with a group ID. And if you use the settings, you need to make sure the pole which you define has the same speed, same DPS, and the same group ID, also with a trunk type. So you can see here there is two different groups. The first one group is use a static trunk type with the group ID 1 on pole 1 and pole 2. On pole 3 and pole 4, we use the group ID 2 and binding together with the LACP. And here's a COI display. You can reference later. And here's the information page. So you can see in the group 1, type display with a static, and the pole defined is 1 and 2. And the group ID 2, the type is the LACP, because that time the pole is not connected, so they will be displayed with a link down pole. And also you can use the COI to check the status. And for this part of this pole trunk is for the LACP timeout. For LACP timeout, they can use to discover the link fail by setting the LACP DU and fail over with the LACP timeout. That means once the pole is broken, then they can use the LACP to check the pole is broken and then block the traffic. So once that time, the traffic will only send from the first link, will not send from the second link. And there is two different settings, long timeout and short timeout. And that is dependent on the durations for the LACP. But the setting is only accepted for COI. So if you want to set up the LACP timeout settings, you should use the COI to finish the configuration. Okay. So the LACP part, actually the pole trunk part is finished. Do you have any questions for this part? Okay, then we can go to next page.
Hey,
For
Johnny,
the,
when
yes.
we're using that, when we're using the short and long timeout, we don't have an option to change the time. We can only select long or short, and that's 3 or 30.
Yeah.
Okay.
There is only short and only long settings can define.
Okay.
There is not able to change the durations for the settings.
Thank you.
Thank you. And the next topic is for the IJMP query and snoopings. For the IJMPs, none for IJMPs. If the network you use is more than 1 viewers, then we can use a unicast or broadcast. If we use the unicast and then the computer is viewers, that means how many viewers you have, how many traffic you need to send out. So the IP cam, if there is 3 viewers, the IP cam should be send out the traffic with different copy for different viewers. So they will have the bad bandwidth utilizations. And also because the camera needs to send out many traffic, so they will make the camera's loading high. With the second option, we can use the broadcast. The broadcast will be flooding all ports in this network, no matter there is a viewer or not. If we will use this status, the camera's loading will be lower, but the traffic will be sent out to all ports, no matter there is a viewer or not. So the traffic will be flooding to everywhere. There will be wasted network bandwidth. So the third choice, we can use the multicast. The typical Ethernet switches will be flooding the multicast to all ports, but if we need to, if the switches support the IGMP, then we can control the traffic to send out the request port. So if we use the multicast and we have a IGMP controller in this network, and also with a IGMP courier in this network, we can base on that to define the traffic should be sent out to which port now. So in this topology, there will be let the cameras has lower loadings, and also the network bandwidth will be used effectively. Okay, then let me explain how the IGMP works. In this network, the layer 3 router is a courier. So layer 3 router will send the IGMP courier practically to check the members of the multicast group. So every every equipment in this network will receive the courier. And the viewer will be report the IGMP report, include which multicast group they want to join. So the layer 3 router will learn how to send the multicast video to this network. And to learn how to forward the multicast traffic effectively, the layer 2 switches should not be IGMP award. For just the layer 2 switch need to know how to read the IGMP message and also do the filtering. The function we usually call the IGMP snooping. And this page is explain how the IGMP snooping works. The Ethernet switches will be snooping from the IGMP report message. So they will be learned from which port is viewer that. They will be save the information with the group port in the MAC table. Then they can based on that to forward the multicast video and only forward the traffic to the port which the IGMP viewer. But in this design, the unknown multicast will be still flooding to all ports as a broadcast. So we have a completely multicast port. For most of it, we need to have an IGMP courier. The usually support on the layer 3 switches. The second one, we need the layer 2 switches should be support the IGMP snooping. In all switches, we support the IGMP courier and snooping at the same time. So the cost is effective and also with a high performance. And here's a setting page. In the IGMP courier setting, we should choose the different version which you want to use and include the interval and the maximum response time. The version our switches support is a V1 and V2. For the V1, they will not include the lift page, the lift package. So if some viewer do not want to show this video, they will be lift silence just with timeout. And if we use the V2 version, once the member do not want to see the video, the members will send out the IGMP package with lift message. And then the switches will notice that there is no one want to see this video and start the stream. And this page is for the IGMP snoopings. For the IGMP snoopings, we need to base on the different VLAN to enable and disable the IGMP snooping. And for the immediate lift, that means that because if we enable that this immediate lift, the device will not waiting for the response, and they will leave the package once they receive the lift message. And this depends on the last member courier interval. And we can check the informations on the IGMP snooping table. This table is displayed the IGMP group which running on the switches. They will include the multi-key address, the ID, and the interface. We can also use the CLI to check that. And for the last part, for the multicast, on the default setting, we will use the unknown. For the unknown multicast issues, the multicast viewer connects directly to the IGMP courier, and the courier will only receive the report from the viewers. So you can see in this touch, the courier is here, and the viewer is here. The videos is only the stream offers. So once the courier gets the IGMP report, the camera stream will be all as an unknown multicast. So we can define the unknown multicast behavior on our switches. If we use the discard settings, the viewer will not receive any stream from the camera, because for the IGMP courier, the all stream from the camera is unknown. Also, we can use the send to all port settings. Actually, this is the default setting on our switches if we enable IGMP courier. But if we use the send to all port, you can see the traffic is flooding everywhere. So there will be waste the bandwidth of the network. And for last one, we have a choice to use the send to courier port settings. That means no matter the group has any viewer or not, the traffic will be only sent to the IGMP courier. In this topology, that will be bandwidth effective settings. So here's the settings on our device. We have 3 different settings: broadcast unknown, discard unknown, and next one is send to queryable. Okay, so for multicast, do you have any questions?
I got a couple.
Yeah.
IGMP is a layer 3 protocol. Does this only work on our layer 3 switches?
Actually, let me think how to
No,
explain
it's a
that.
layer 2.
Actually, there is a layer 2.
It's a layer 3. It's a network layer protocol.
The query is a layer 3 part, but if we only use the snooping, that is a layer 2 function. So what's your questions for this part?
So it works on, are you saying it works on all of the managed switches?
Yes.
That's also what I'm used to.
I mean, just looking at the pictures, it looks like there needs to be a layer 3, but then everybody in the middle could be layer 2.
Actually, if we want to use that, we only have to use one layer 3 switches as IGMP query, and the other switches in that network only need to IGMP away. That means they will be only that if the switch can support the IGMP snooping, then the switch is layer 2 or layer 3, there is no matter.
Okay. There's also, when you looked at protocol versions, you looked at version 1 and version 2. There's a version 3 of IGMP. Do we not support that?
Not yet.
Okay. And are there any other multicast protocols besides IGMP that are supported, like protocol independent multicast, PIM, or any of the other protocols in multicast on the Cornix product line?
I need to check with Andy a bit better, but if you want to make sure the traffic can pass through our switches, and also you want to enable the IGP snooping, I will suggest to use the unknown floodings to make sure the traffic can pass through by our switches. Because if we set it with unknown discount, the traffic may be dropped by our switch.
You have any experience with a Cornix switch being part of a broader network with other switches, other manufacturers' switches, and in how they handle multicast? Do we participate pretty well with them? Or the proprietary things that we're doing?
Because for the multicast, we have different parts. Some part of multicast protocol is like the OSPF or some spatial protocol that is using the multicast to send the control package. And for that package, our switch will not know what is that. So for our switches, that is an unknown multicast.
Sure. You mean like multicast OSPF or multicast BGP or some of those other protocols, right? We don't, it's unknown to us.
Yeah, that is unknown for us. So
all right,
you can use just an unknown flooding, then we can make sure the traffic can pass through on our switch. But if you use the unknown drop, there will be drops.
All right, thanks. That's all my questions.
Okay, thank you.
So just to review, I've got a question too, for my knowledge, just to review.
Yeah.
In order to support IGMP snooping, we have to have at least one layer 3 switch on the network, and that will be the querier.
Yeah.
A layer 2 switch cannot be a querier.
Yes, but our switches, even though these are layer 2 switches, they will still support the IGMP querier. But you need to make sure the switches mentioned VLAN and the querier is in the same, and the IGMP element is in the same lane.
Okay.
Because our switch is layer 2, so that is only have one IP interface.
Thank you.
Okay, thank you. So do you have any questions? Okay, if not, then we can go to the next topic. Then for the next topic, there will be a simple topic that is called the link layer discovery protocol. We usually call it LLDP. For the LLDP features, there is a 802.1 AP link layer discovery protocol. They will periodically update the system information to the network management systems. The information will include the device information, port IDs, VLAN IDs, and so on. To configuration the LLDP, you just enable or disable that and choose the LLDP timer. This timer settings is using to update the frequency. And also the LLDP hold time. This settings using before discussing discarding. This setting usually suggests to follow the MS settings. Sorry, the MS request, or you can just keep it default. And after set up the LLDP, you can check information on the LLDP port status. But if you want to see the information on this page, the neighbors of the switches also need to enable the LLDP. And the two switches can discuss the information by the LLDP and show the information on this page. For this example, that means on the port 2, there is a number switches with this MAC address, and here's the member's IP address, and this is the VID which the member uses. Also, you can show the information by the CLI. By the CLI, we can show additional information about the TTL. It is a less time update by the LLDP.
What is that used
Yeah.
for? I mean, you're able to see what switch is connected to which switch, but what kind of history are you looking for when you're using this neighbor information mode?
Actually, if you use the MS or other functions, you can use this information to create a network touch by the applications. Because following this information, you can show a switch is already connected on the port 2. And on the port 2 switches, they will show the information on the equipment which connect on that. So you can base on that to display all the patch in this network if the equipment in this network all support the LLDP.
Okay, thanks.
Okay, thank you. And also because the LLDP will be updated practically, so you can also based on that to check the neighbors is still alive or not. So do you have any questions on this part? If not, then we can go to the next part. That is a simple network management protocol, which we usually call the SMP. This is usually the usage patch which we used with the SMP. For this different equipment, that is binding on the NMS. So we can use the ARON, the device discovering and the device management. And for this part, there is the engines for the SMP. And for agents, usually that is our switches. And we have different behavior, like the read-only communications or the read-write community. And here's a SMP define. In this topology, we'll have different equipment. The first is the NMS. It's called the network management systems. That is a control application in the network. SMP, which is used to discuss between the MS and the engines. The management devices is the device which installation the MS. So in the devices, we also will store the management information base, which we call the MIB, the main file. And the engine, just as I said before, there is a network improvement, which is SMP await and can be controlled by that. For the community, there is a password to discuss between the MS and the engines. Our switches can support 4 community name at the same time. And there will be different type, like a read-only. If you choose the read-only, then if the MS use this community, then they can only read the informations. The default name is public. In the read-write community, just as they say, if you use this community, the MS can read the information. Also, they can use the community to set up the settings on our switches. The default is private. And here's the example of the MS tool. In this example, I use I read them in browser because it is a free used application. For these applications, in the first part, I upload the MIB file of our switches, so we can, based on this, to find our equipment MIB file. And after that, we can check a different SMP object. For example, in this part, there is a system name. The system name just like our switches naming. So they will include the object ID, name, reach, and value. And here is the MIB information, include MIB table name, object ID, object name, and the MIB values. And for the equipment, they support the get next, get bunk to about read function. And for the write functions, they support the SMP set. And here's a management information base, which we call the MIB file. There is collection the information for our equipment with different functions. So we can base on the different object ID, which we call the OID, to binding with functions which we can set up on the GUI or on the CLI. And that is why when we release a new firmware, and we have a new function on the switches, then we will also release the new file at the same time. For the SMP configurations, we can use a V1, V2C, or the V3. For the V1 and V2C, we only use the communication name and the privilege. Just as I said, like the public, private, read only, or the read and write. If we use the V3 versions, then it will include the username, security table, and also the authentication. Like this. And the setting should be confirmed with the MS settings. The setting should be the same. If the setting is not the same, the connection will be not able to set up. And then next part is the SMP trap. The SMP trap is using to send the notification from the switches to the MS. For our switches, the first step is is to set up the event section. For example, if we set up the event section with a link status on the port 1, and finish the SMP trap settings with the server IP communicated version. Once the port 1 is down or up, the switch will send the notification for the to the MS. So we can based on that to do the control or send the alarm to the MS to let them know something happened on our switches. Okay, for the SMP part, do you have any questions?
Is there anything on our website that tells people about our MIB and how we're supporting SNMP?
Sorry, can you repeat again?
Is there anything on our website or any information where somebody could find out what SNMP features we support? So like a company that's using a network management system in an MS, they want to know what they can see on our product.
Actually, there is two different parts. The first part is that if you use a correct MIB file, then the most function on our GUI will be also supported by the SNMP. But if you say which application or other things can control our switches, they depend on what the customer wants to use. Just as I said in this example, if I use a MIB browser, they can do the read and write functions on our switches. But I think they cannot fulfill all the customer requests because this is too simple.
Maybe my question is where is this sort of documented other than in a PowerPoint presentation where somebody could see this information?
These informations, you means
outside of having to, be connected to one of our products and looking at it,
on the spec sheet most of the time, Jeff.
I don't know where there's a spec sheet on this, on NMS, on our SNMP. I've never seen anything that would tell anybody about our SNMP abilities, is what I'm saying. And I just wondered if there was something out there that we could give somebody. If somebody asks us, tell us about your SNMP. The only way we could probably do it's through the presentation or something that I'm seeing.
Yeah, actually, for the SMP, that is only engines like the COI or the web GUI. So if something you can control on the web GUI or COI, they can also use the SMP to do the same control. They should can. But if you want to see what they can do on the MS, that depends on that MS applications. This can fulfill your questions. Wait a moment, please. Okay, maybe we can discuss later by Teams or other things for these questions. Yes. So, do you have any other questions of the SMP? If not, then we can take a break for 5 minutes. Then we can start from the security features.
Sounds good.
Okay, thank you.
Hey, Jeff? Jeff? Hey, take a break.
Okay, is everyone back? Okay, well, we wait for 1 more minute and then we start.
Thanks for staying up late. I know it's about midnight there, so appreciate it.
It's okay, because there is only 2 topics in these presentations.
Say that again.
There is only 2 topics in these presentations,
Oh, okay.
so I think they will be not take a long time.
Okay.
Okay, then we go to the topic about the security features. For the first topic, we discuss about the general security features. For the first part, we call that there is a major VLAN. The major VLAN that means to control the VLAN which can to connect to the device controller interface. So if the client do not belong to the VLAN 99 in this page, even the IP address in the same subnet, the clients cannot access to a switch's major interface. So we can use these functions to keep the device management interface is simplified with the user's VLAN and to make sure the device is safety in this network. And these are some tips of the major VLANs. On our switches, there is only accept for one major VLAN. And only the client in the major VLAN can access to the switches. If the client is in different VLAN, even that is not same network, that is not accessible. And just as I said before, the IGMP courier need to be applied to the major VLAN because there is layer 2 switches. There is only have one IP address. So if the courier is in different VLAN, there is no IP interface. And the management VLAN is a must settings on our switches. The default setting of the management VLAN is VLAN 1. And also the VLAN 1 is a PVID for all ports. So once you get the switches, you do not need to modify the settings. You can use a connection to access our switch. Okay, for major VLAN, do you have any questions?
What is the network that VLAN 1 is assigned to?
Sorry, can you repeat again? What is a network VLAN? Oh? Oh, can you help to repeat the question again?
Yep.
I think you said, go ahead.
What is the IP address or the network address that is assigned to VLAN 1 by default?
Oh, okay. The default management IP address is the 192.168.10.1. It's a default IP address with a subnet mask which is 24.
Thank you.
Thanks.
24-bit subnet.
Yeah.
Thank you.
Thanks. Okay, And we can go to the next topic with port security. The port security that is using to binding the port and the MAC address. So only the correct binding can access to the switches. For this example, there is not enable the port security. And once we enable the port security, then only the setup settings with a correct MAC address can access to the switches. And here's the configuration of our port security. For the first part, we need to check the PC's MAC address. We can use IP configurations /O to check the physical address of the IP. This is for Windows. If you use Linux, you can use the ifconfig to display the MAC address of the PC or other equipment. And then we can go to the add the port security entrance to input the informations, include the port, the VLAN ID, and the correct MAC address. And then we can check that information on the show port security list. After setup, for this example, only this MAC address with VLAN 1 can access the switches on the port 6. Okay, so do we have any questions? I think this is a simple feature. Yeah, if not, then we can go to the 802.1x. For the 802.1x is a IEEE standard for port-based network access control that provide an authentication method to devices, which is to attach in the LAN or the LAN. In this example, this authenticator will be our switches, and this is a client which want to access the network. So they will use the EEPROM to discuss with each other to do authentication. And here we can use the authentication server. Usually we will use the radius. So once the supply send the EEPROM to our switches will, based on the information, through the radius to discuss with the authentication server to make sure the authentication is correctly or not. If that is correctly, they will pass through the traffic and allow the supply to access the network or the LAN. And here's the protocol process. First, the client will send out the EEPROM start to our switches. After reply the identify, the device will reply with the EAP response with the identify that is using to do the authentication. Our switches is the engine to send out the radius to the radius server. The radius server will reply the radius access challenge to the supply code. And for the client will based on challenge to response with the radius server. And the radius server will based on the access request reply to feedback the access is passed or not to our switches, and our switch will pass through the information to the client. And for this part, we need to notification that the client need to be a 802.1x await devices. If that is not await, then this authentication will fail. And here's a setup on our web page. For the authentication method, we usually suggest to use the radius, but also our switches also support the authentication method with local. That means we can use username and password settings on our switches to do the authentication. For the first part, we need to define the radius server, which we do the authentication challenge. We need to put the IP address, share key, poll, and accounting poll. And also with the radius, for local radius users, we need to input the information with the username, password, and also with the VID. And for the poll controller, we have 3 different settings. Auto means we enable the authentication mask. Once we use the auto, that means the client can do the authentication of the poll. If we choose the false authentication, that means the authentication on the poll will be not doable. The traffic will pass through. If we use the false authentication, that means the poll is blocked by the 1x function. The MAB, that means to enable or disable the MAC authentication by bytes. The re-authentication, that means this poll need to do the authentication again or not.
A question on forced authentication. You go back one page. Forced unauthorized port is blocked. You would use that, for example, like if you knew specific ports on a switch, physical ports were ones that you didn't want anybody connecting to. You just wanted to disable them. Is that right?
Yeah, they will be blocked all traffic.
Okay.
Actually, you can check this page with the admin control direction. It will based on that to block the traffic with both or with both or only the in traffic.
Right.
But what is it also possible just to administratively shut the port down manually?
No, there is only the both and in, not the out.
Okay.
Yeah, because in we can control the traffic to drop, but out there is not defined by it. And for the max request, that means the client can try how many times to do the authentication. The guest PN, that means you can define that the authentication is based on which VLAN. If we keep it 0, that means the poll will block all traffic once the authentication is failed.
The first one says the maximum number of retries to supplicant. What happens if they reach that maximum request? Is it disabled temporarily, or how is it reset?
As I know, they should be blocked. If you want to reset, maybe you should for this part, I need to double check with ID.
Right.
Okay, thank you. I will update the information later. And for the host mode, there has 2 options: single and multiple. Single, that means the traffic will only allow the traffic will only allow the authentication equipped device. But if you choose the multiple, that means if the poll have okay, for example, if the poll is connected to the other switches and the switch is connected to about 3 PC, if you choose a single, that means the first PC which finish the authentication will be allowed to pass through the traffic. But if you choose the multiple, only one PC passes through the authentication, then the 3 PC can send out traffic out. And then next one is admin control direction. Just as I said before, if you choose both, they will drop all traffic through the incoming and outgoing traffic. And if you choose the in, they will only to block the outgoing traffic. Okay, yeah, here. This page is using to control timing. The first is a re-authentication priority. That means how long they can try the other times to do the authentication. And the secondary is a quiet priority. There is time to do the next radius access request when it fails. And the third is a T-star priority, the time that is using to set up the time interval for a EAP request. And we can use a website to check the status. For this example, if you choose a false authentication, because if you choose this function, that means the poll is already accepted for all clients. So there will be not show any information on this page. But if you use the auto, they will display the correct successful authentication on the poll. For example, on this poll, that means the client with this MAC address is finished authentication. So they will display it here. Okay. So for the 1x part, do you have any questions? Okay. If not, then we can go to the other part. This part will introduce about the ACL. The full name of that is Access Control List. For ACL, for the purpose and benefit of the ACL, first, we can use that to do the packet filter and then present the unauthorized devices to access the network. Also, we can use that to isolate the traffic between the different subnetworks, restrict access to network resources. And we can use that to filter the unwanted packet from the edge, which cannot be controlled by a firewall. For the ACL, that means the contrast list of the access control entrance. So for each access control entrance, we'll specify the permit or deny some action, and also set up the conditions of the package must be certified in order to match the access control entrance. For the ACL, we have 3 types. First is MAC address. Secondary is the IP standard. The third is the IP extender. We will show the detail for you later. And here's the process of the ACE, which we call the access control entry. For ACEs, there is a rule called the deny or permit, and we can base on the IP or MAC address to do the filter. Also, include the protocols like UDP, TCP, ICMPs. And if we use the IP address as a access control entrance, we also can include the address of the target. And we can use to filter incoming package to create the access list and edit the create rules. And then after finish the rules, we can bind the list to a pole which we want. So here's the processing of the access control list. Once the package enters the switches, they will pass through the different access control entrance and then go to the outbound checking. If they pass, then we will go outgoing. They will be sent out. And here's the rules of the access control list. For the last page we saw, there is only one access control entrance. And if we binding multiple access control entrance together, there will be as an access control list. So for this example, once the package enters the switches, they will match the first access control entrance. If passed, they will based on the settings to go to a permit or denied. But if a traffic is not matched, they will go to the secondary. And based on that, to check the action. And if that is still not matched, they will go to the next one until the last access control entry. So an access control list is a secondary list which has several rules. If that is matched, they will follow the actions with a deny or permit. But if that is not matched, they will be skipped to next rules. This is an example. This is a different access control list, which I said before. They include the IP-based access control list. They can only filter by the source IP address. And the other one is extended IP address access control list. In these settings, we can do more different type of the access control entrance. They include the source or destination IP, product type, and the TCP or UDP port if you filter with TCP or UDP. And the last one of the access control list type is a MAC-based access control list. This type, we can use that to filter with the source or destination MAC address, and also with the Ethernet frame type. This is an example for the access control list settings. On the first one, we need to, if we want to use a MAC address filter, then we need to create a rule first, and then set up the filter settings. This is just as I say, the permit or deny, and input the MAC address, white car, and if you want, you also can input the essential MAC address. And also you can define if there's pole or just to keep the traffic. And after that, we can see the settings on the MAC filter list. For this example, the setting is with the action permit, with a source MAC address, and the other one is keep the same. So once the switches catch the traffic with this MAC address, they will pass through with the MAC address table to send out the traffic. It will be not dropped by the switches. And if we want to use the IP filter, then we also the same. We need to edit the group name of the IP filter first. And this example is for the extended IP address access list. So we can set up with the source IP address, source pole, destination IP address, destination pole, and the protocol at the same time. And here's an example for access control list with IP. It's a group 1, standard mode. The source IP address, the processing is permit. So once the switches get the traffic with this source IP, they will pass by our switches. And after finish that, we need to attach the filter to pole. So we can base on this page to do the filter. Okay, so for the ACO, do we have any questions? Okay, if not, then we can go to the next topic for the cybersecurity features. For cybersecurity, we have 3 topics. The first one is DHCP snooping. The second one is DAI, and the next one is IP source code. We start from the DHCP snooping first. For the DHCP snooping, to introduce these functions, we need to know how the effect for the authentication server, authentication DHCP server. Usually, if your PC get the IP address with the authorized DHCP server, that means the IP address should be able to access the network with a promise, and the function should work smoothly. But if the PC get the IP address from the unauthorized DHCP server, then you cannot make sure the service of the network will be worked normally. So if you face to this problem, then the client may face to the issue, which is fail to access the network or the traffic will be redirected. Then you may face to issues with the sniffer or the majors. So for the DHCP snooping, they will be acted as a firewall between the DHCP client and the DHCP server. So they can ensure the client is able to obtain the IP from the authorized servers. Also, prevent the DHCP attack or mistake. For this topology, that means they define this pole as a trust pole of a DHCP. That means the authorized DHCP server is connected on this pole. So if the other actor or an unauthorized DHCP server is connected to the other switches, they will be blocked by the DHCP snooping. Because in this topology, they already know the trust DHCP server is connected on which switches and which pole. So they will have 2 different characters in these functions. One is the trust pole, and the other one is untrust pole. The trust pole is using to connect the authorized DHCP servers, so they will forward DHCP message without any block or any drop. But if you choose the pole as a trust pole, the DHCP ACK and the DHCP offer from that pole will be dropped by our switches. And please notice that the DHCP snooping binding table will be only collect and shows the information from the untrust pole, because usually the client will connect to the untrust pole. So the switches will based on the information to collect the information from the client, which get to the DHCP settings on the server. And to configuration the TCP snoopings, we need to define the VLAN first because it is based on the VLAN to do the snooping settings. And we can base on different VLAN to enable or disable the TCP snoopings. And also to use CLI to do the setting to define the pole is trust or untrust. Also, if you do not want to use the dynamic DHCP settings, we can also use the DHCP bind table. That is a static binding rules. We can use that to define the IP address is binding with the which MAC address, include the VLAN ID and the interface. If you use that, there will be not affected by the DHCP snooping function because data is static. Okay, so for the DHCP snooping, do you have any questions for this part?
So in this case, I'm trying to figure out how you set the authorized DHCP server. Is that what you're doing here? You're manually saying the DHCP server has this IP MAC address, or am I missing something there?
No. The DHCP server, you only need to connect that on the trust pole. Then you do not need to do the other configurations because the DHCP server will use, usually the DHCP server will use the static IP address, and that server will offer IP address for the other command. And this snooping function is to make sure the DHCP server is trusted. And if someone connects the other DHCP server on the trust pole, the DHCP offer function will be blocked by our switch. So we do not need to set our DHCP server setting on our switches. Just make sure the pole connection is correct. So is this okay?
Yeah, I had one other question back earlier, not related to DHCP. We were talking about on authentication.
Yeah.
When you were referring to Radius, I mean that protocol, I think it was created before Jay was even born. That is an old protocol. Is it still used? I mean, I wouldn't think.
Radius or other things.
Yeah, for an authentication server, I wouldn't think anybody would have using Radius. I mean, it was set up for dial-in is what it was set up for when it was designed. And I think most people have, they don't use that. They have they have other, authentication systems in their units. I'm just trying to think if anybody here on the call knows, is Radius still used? What do people use for authentication for stuff like this? I wouldn't think they would use Radius, but maybe I'm wrong.
Actually, as I know, Radius is still used some area, but some parts of the equipment using TACAX Plus. And
TACAX, yeah. Again, those are like 25 years old. They've been around forever.
Yeah,
I just can't believe they're still used.
Actually, that is still usable because that is using to as a center to control all equipment. They only need to do the authentication recall on Radius server at one time. Then you do not need to put the recall on every equipment. And just as you say, that is all equipment. That is an old protocol, so there is some security issues. As I know, some Radius will combining with the SSH functions to make sure that the connection is more security. But our switches right now is supposed to use the basic Radius.
I was just thinking about like the stuff that we work on, at least our IT people, right? They use, it's sort of a Windows, Microsoft world where we have single sign-on and things like that. And I just didn't think that for authentication levels that we would use something like a separate authentication server, that we would use some existing one for for a company that wasn't Radius?
If you say about the Windows, for Windows Windows 2012, they still can use the Radius to do the authentication, but also you can use the AD domain to do the control.
Nope, come on.
Yeah. Sorry.
Do you have a comment, Josh? Your microphone's on.
Oh, no, sorry about that.
Okay.
Okay, so yeah, but our switch is right now still using Radius, and I'm not sure they have an improvement plan or not.
All right. Thanks.
Thank you. Okay, and after finish the DC part, then we go to the DAI part. They usually called the dynamic ARP inspection. For discuss this part, we should talk about the ARP spoofing first. For this example, the client A uses IP address 10.0.0.1. The MAC address is A. The client B uses IP address 10.0.0.2. MAC address B. As usual, if they want to discuss with each other, then they need to use the IP address with the MAC address to send out traffic between the two PC. And if someone wants to do the ARP spoofing, then they will flash their ARP cache as actually the IP address is still the destination IP address, but the MAC address will be flashed as client C. So you can see the ARP cache. The client B wants to send the traffic to client A, so they send the traffic to 10.0.0.1. But the MAC address is a client C's MAC address. So the traffic will not directly to the client A, will send out to the client C first. And then client C can do whatever they want. And to protect for the actor, we use dynamic ARP inspection. This function can protect from the ARP spoofing and the ARP cache poison detection. They can read ARP protect package and discard invalid IP MAC address table binding according to the DC spoofing or static DC binding. So the two functions should be used together. And this function can keep the MAC address table correctly. Just for example, if we want to use if someone wants to do the ARP spoofing, they will reply the MAC address is with the incorrect MAC address. For example, this page, the client A is asking the MAC address with the client C, just this client. But the client B want to do the ARP expression. So the ARP spoofing. So they reply this IP address C, the MAC address is B. So the traffic will be sent from A to B, not to the client C. But if we enable DAI functions, it will block this behavior with the DC snooping table or snooping or static DC binding table, because the switch already knows the IP address C, its MAC address is a MAC address C and the MAC address B. So for the configuration of these functions, it's more easy. We just need to enable, disable with a different VLAN. And also, if we want to identify the gateway, we can also input that. And also define the port is trust or untrust to make sure the MAC address can be refreshed. So for DI, do you have any questions? If not, then we go to the next topic. For this topic, there is the IP source card. For the IP source card, there is prevent. For this part, there is prevent for the up spoofing, and this part is provided from the IP address spoofing. For this function, there will be validated incoming package and drop the package that is contained in valid IP address. To enable the IP source card, they usually use with the TCP snooping table. No matter the dynamic IP address or static TCP or the static TCP binding. So if the TCP snooping binding table is not existent, we should use the port ACL, not using the IP source card. And the IP source card will not only check the IP address, but also check. The IP source card will not only check the but also check the all track through the pole. Because the IDG is only check the R and the IP source card is check the pole, they will check all track. The IP source card will be discard the package that is do not match the TCP snooping binding table. And for this setting is also simple because that functions table is running from TCP snooping functions. So on these functions, if you want to use that on the correct pole, then you should choose a trust, manage as untrust, and also choose the IP source card function with IP with MAC. Okay. So for this topic, do you have any questions? Okay. If not, because this is the last topic of today, do you have any question for today's presentations?
No, it's very good. Just please send us your slides.
Yeah, we will. We will send out the slide. With I will discuss with Johnny. We will send together or one by one, and then update that for you.
Thank you.
Thank you. So, if there is no questions, thanks for joining today's presentation. Have a nice day.
And
You too.
likewise, see you next week.
Okay.
Thanks,
Thank you very much.
Bye.
See ya.
Bye.哎，周宇啊，我问一下哦，
哎，
就是那个刚刚有一位在问那个 SMP 那一块，他的问题到底是什么？是我听错了吗？
你说 SMP 那个对不对？
对啊。
他意思是说我们有没有专门在讲我们那个，就是讲我们 Switch 在 SMP 这块可以做到什么程度啊？他意思是这样，但是
就是
我应该没有。我刚找一下，我们没有特别在讲 SMP 的东西。
对，因为我刚
只有在 user menu 里面有讲解一些，就是讲设定啊。我觉得应该是没有。
对，没有，因为有时候我刚刚才跟大家解释说，就是事实上故意的做到其他们都可以做 SMP。
对，
我是发现这样。
他意思很简单，就是他们有些客人可能会问说，哎，那你们 SMP 可以做到怎样？然后他意思说，我们有没有什么 document 可以跟他讲说，哦，我们的 SMP 可以做到什么程度，大概有哪一些东西，就是在 document 里面，就是一份 document， 类似一个 SMP 的，算 user menu 吗？或算一个 guide， 就是专门 for SMP 这样子。但我们应该没有类似这样东西啊。
对，因为其实就是这也是为什么刚刚跟他解释说，其实就是你自由安全做到什么东西，那 SMP 就应该要理论上啊。
对啊，对啊。但我们应该没有类似的东西啊，我们没有针对 SMP 做一个独立的 document。
就是都是混在各地，或者说是单纯跟他讲说这个有个 gaming file，你要用自己拿去用。
对啊，但我觉得这个好像不是一个必要的东西啊，我觉得，因为这个没有很
应该是说会用 SMP，其实通常就是给他一个 file，他大概就知道怎么用。他不会用的，你看的那个文字袋还是考不是他在干嘛。
对啊，他的意思其实蛮简单，他的意思就是他要有一个客人问的时候，他们可不可以直接提供他一个文件，让他知道我们 SMP 可以做到哪些事情，然后可以做到什么程度，他大概意思是这样。
对，可是因为这个东西就拿硬壳 RB 提供，因为我们也不知道在做什么。
对啊，
而且这个还是 by device，不是 by function，因为每一台状况其实不太一样。
哎，明天我再问一下，明天我再跟 PM 讨论一下好了，看我们是不是有需要，但我是觉得不需要啊，不应该是不太需要做这种东西，因为意义
因为
不大。
这种公司，对，因为
会问
也没办法，你没办法提供一个他们的文件出来，你一定是 by device，因为每台行为其实不太一样。那这个可以要怎么做？
那还好，我们家 SMP 基本上都是，因为他们没有动过什么东西，基本上每台都差不多。
都是共通的，
是
可是不是有一些加方选或减方选，它 MIB 不是应该要 post 动？
有是有，但是都是加那个单加减方选，我觉得倒还好，因为它这个药其实只是一个 overall 介绍整个我们的 SMP 做到什么样的地步而已。但是我觉得这个是个必要的事情，因为真的我不知道美国那边真的有很多客人问这个吗？就我们这边遇到的其实不太会有客人问这个。
其实有可能是因为要看他们有没有考虑要用到中控系统，如果有用到中控系统的话，就会用到 SMP。可他们如果可以接受一台一台去做 configuration，其实没差。
对啊，这倒是有可能。不过我觉得可以，反正明天问看，或看 RD 那边有没有什么文件可以拿来改一改。对啊，我们再问他们好了，反正这个可以记下来，这个可以记下来，就是当成一个客人提的 request，到时候开会的时候我们也可以提出来。
不过因为我是觉得这个 request 其实有点 rough 啊，就是你要提供到什么程度，其实也不是很难讲。
对啊，对啊，我觉得这个不是一个很 make sense 的事情。对啊，不过我觉得没关系啊，就先这样，我们就先当个记录就好。
好，谢谢啊，今天麻烦参加。
OK，对啊，赶快休息吧，对啊，也12点半了。
你也是在休息。
OK，好，晚安。
谢谢，晚安。
好，拜。